Hi ladies and gents, this is Ms. Peterson. We are now going to do assignment number 4, information. So the Schoology says that you need to write a hypothesis. So if I go ahead and look at my situation or my scenario, it's a little different than yours. So there's this rat, and there are some rats that have this electrode stimulation hooked up to their brain. And their hope with what they say is that this stimulation will cause a decrease in food intake. That's their hope. It may or may not, and then they need to check that and make sure. And so you'll notice that they did 10 trials. They did some with stimulation and then some without stimulation. And so we need to write a hypothesis. So it needs to be something like, if stimulation occurs in the rats, then when they're given food, in this case chocolate chips, the rats will eat less because the electrode causes the receptors to not work, whatever it may be. So you need to make sure at your hypothesis that you write an if, then, because statement. So if something happens, then there will be a reaction or result because, and then explain. Your null hypothesis, remember that that's the opposite. And so the null hypothesis would say that there's going to be no difference between the rats that eat a whole bunch and the rats that eat nothing. That get stimulus or no stimulus, and looking at how much they eat. So you then need to do a t-test to see if that is accurate or not. So you go to this graphpadcalculator.com. I'll put the link on Schoology. And you scroll down to the data section. You can't copy and paste, unfortunately, so you just need to type. So this group 1 will be my stimulation. This group 2 will be no stimulation. And I go ahead and enter my numbers. So 12, 7, 3, 11, 8, 5, 14, 7, 9, 10. Once I get done with those 10, I need to remember to hit enter. So you'll notice that now my cursor is in number 11. That's appropriate. Then we go to group 2, 8, 7, 4, 14, 6, 7, 12, 5, 5, and 8. And then again I hit enter. So I've selected both of these columns. Even though I'm not going to put anything in there, that's okay. Then I leave everything as is and I hit calculate now. And it will give me two things. It will get me a t value and it will get me a degrees of freedom value. So I'll also, link the critical t value chart. And remember, you are looking at a 95% confidence, which would mean a 5% error, right? So, you want to find one. Bummer. Okay, so I finally found the table that we pulled up in class. Sorry. So you're going to want to make sure to go to the two-tail test of 0.05 because that's a 5% error. And then if you remember, if you pull this t-test over here, we had an 18 degrees of freedom. So if we go down to 18 and over to 0.05, the number has to be higher than 2.101. And you'll notice that it's actually 0.6 in this case. So this number is not higher than the critical value, which means we have to accept our null hypothesis, meaning that there is no statistical difference between when the rat is given stimulation and when it's not given stimulation. You can kind of see that by those numbers, that they're kind of very similar to one another. So it wouldn't be surprising. They share a lot of data points, which means their error bars would overlap, which also means that it shouldn't be statistically significant. So we would in fact accept our null hypothesis. So I hope that makes sense. That's all I have for you. Thanks.